platelets, very important, like we've said. We're going to look at some of these functions, what they're going to do. So what they're going to be able to do, they're going to be able to secrete vasoconstrictors. So now we're looking at the blood vessels and closing them, because if we've had a breach to that area, we want to actually stop the blood flow. They're going to have the ability to stick together, form what's termed the platelet plug, and for the breaks that are occurring, seal that up. They're going to secrete a procoagulant. This chemical, known as a clotting factor, and help promote the clotting that's needed to stop that blood loss. They initiate formation of a clot-dissolving enzyme when it's needed, chemically attract neutrophils. Neutrophils are what? They are our biggest antibacterial. They're high in number and very readily available. And they were known as our first responder. So the platelets can attract neutrophils and then monocytes, which were the what? Table 2. They are going to be the cells that go in and they'll have phagocytize, all right? If they can't take care of the invaders of the body, they'll become the antigen presenting cell. Because one of the things that we want to do, we want to destroy anything. Because if we have a breach, especially to the outside of the body, we want to control what is trying to invade the body. Then they can secrete growth factors that will help stimulate mitosis. Table 4. What is mitosis? The cellular division, okay, in the blood vessels. Meaning the blood vessels can repair. All right? So, when we look at the platelets, there you go. They're not a true cell, okay? They are just simply a fragment. They're going to have granules located within them. They're going to have this canalicular system, and they're going to have mitochondria because they're pretty busy. This is that megakaryocyte, where sitting here in this like trabeculae of the bone, and look how it's kind of just hanging out there, and as blood flows by, little pieces get ripped off, and those little pieces become the platelets. So they're not a full cell at all. The production of the platelets, this is termed thrombopoiesis. So we've now had hematopoiesis, leukopoiesis, red blood cell, white blood cell, thrombopoiesis for the platelets. It's termed thrombo because the platelets can be termed a thrombocyte. And so you'll usually see them termed a thrombocyte. There is a stem cell. It gets exposed to a chemical called thrombopoietin, and that turns that stem cell into the megakaryocyte. And it just basically is there letting the blood flow by, ripping off the little pieces of it. And that's what it does. We get that thrombopoietin from the liver and the kidneys. So that's where that chemical is going to come from. Now, this production gives us that megakaryoblast. We're going to have that cell become the megakaryocyte, and it'll just simply sit in the bone marrow. There's usually this little sinus, this area where it will sit. This cytoplasm just swinging out there in the blood flow, and then those fragments get ripped off and the platelets circulate. They'll circulate for about 5 to 6 days, and then they'll get stored in the spleen. They'll be taken care of in the spleen. When we have when something breaches a vessel and the vessel breaks and we have to stop the blood flow, we have these 3 mechanisms, okay, that are going to help stop the blood flow so that you don't end up bleeding out. That vascular spasm, platelet plug formation, the coagulation. Now, note when we look at the structure of a blood vessel, what are you noticing that they're trying to represent here in this structure of the blood vessel? Looks like a tear in it, and that tear looks jagged, right? Because there are fibers that are present, okay? What are the 3 fibers of the body? Collagen, reticular, elastic, all right? And depending upon if we're looking at large vessel, smaller vessel, down to the capillary, it will help us determine fibers. So now, not only do we have a break, okay, but we've got some, what looks like some fibrous material, some jagged material, all right? Red blood cells, all right, that are going to be able to like escape through the breach. The platelets. Over here, when that breach occurs, platelets are like, hey, whoa, no, we can't have that happen, okay? We can't have this loss of blood. We got to keep it enclosed in this vascular system. So they can form that platelet plug, and we end up getting some formation of these fibers that create a net. And if we can create that net, what gets backed up into it? Huh? We got the platelets that'll back up into it. Any of those white blood cells that might have gotten there, we're blocking it. And then, what else could those platelets do to the vessel that it's blocking up? it's going to stimulate the mitosis for the repair. Now, does this occur quickly? The stopping of the bleeding does. But what about the actual repair? It takes a little bit longer, okay? Longer for some, shorter for others. So, in hemostasis, the stopping or the cessation of the bleeding, the vascular spasm, that first step, we want to do something to constrict that broken vessel. This is our immediate response to the breach of that blood vessel. Causes of this? Well, sometimes pain receptors are involved. In other words, when the breach happens, we know it's happened because there's some type of pain that's associated with it. We can have a smooth muscle injury. Remember how I said things are happening 24/7? It's breaking, fixing itself, breaking, fixing itself. We don't even know it. Okay? This is what's taking place. Sometimes we can have the release of serotonin, something that's going to help constrict those blood vessels. The goal with the vascular spasm, do something to stop the blood flow. And if we can make that vessel begin to constrict, we're going to help to stop that blood flow. The vascular spasm, very prompt constriction of a broken vessel. Depending upon where the breach occurs, do we have a breach that's to the outer portion of the body, or is it something, like I mentioned, taking place in the body all the time? One's to the outside of the body, most likely we're going to be aware of. Okay? Some type of pain is associated with it, like a paper cut, for example. Paper cut, don't you love them? And then you stand there and you actually watch it stop bleeding. Ever done that? Because there is a time associated with it that it should stop within this amount of time. If not, something's wrong. Yeah, it's really kind of cool. Now, this vascular spasm, it's going to allow for the other two pathways, which were what? Platelet plug formation and coagulation. Those take a longer time. When we have the platelet plug formation, those intact vessels that haven't been breached yet have a smooth endothelium. The tissue makeup, the cellular part, it's coated with something called prostacyclin, a platelet repellent. What? Explain that one to me. An intact vessel. Does my intact vessel need the platelets to be forming a clot? No. So therefore, they don't want a clot in that vessel because that becomes what? A problem. It becomes a blood clot. So we can't just go around having these little vessels be clotting up. All right. So as long as it's intact, we're good. Platelets are just woo 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 through the blood. All right. Now, when the vessel breaks, oh, it made me think about that little lullaby. When the bow breaks. Never mind. Okay. It just made me think about that for some reason.